Here we're given the function f of x is equal to tangent of x, and we are limited to looking at the function only on the closed interval 0 to 2 pi. And we're asked to find within that smaller interval what are the intervals on which the function is increasing or decreasing. So once again, we're going to need to find any values between 0 and 2 pi that are not in the domain of the function, and we're also going to need to find any critical numbers of the function. So let's look for both of those. I'm going to start with the critical numbers. F prime of x is going to be equal to the secant squared of x, which I'll remind you is 1 over the cosine squared of x, and that may be a more useful way of trying to figure out what's going on with this. Secant can't ever be 0, and we can see that from rewriting it as 1 over cosine squared of x. It will be undefined whenever the cosine is 0. So where is the cosine 0? Well, let's consider that. Cosine of x is equal to 0. That's going to occur when x is pi over 2, and again when x is 3 pi over 2. Those are the only 2 points in the interval 0 to 2 pi. Now those also happen to correspond to values that aren't in the domain of the tangent, because the tangent's sine divided by cosine, so we're also going to pick up zeros of the cosine for vertical asymptotes. So we kind of end up repeating the information in this case in both places. From that information, though, we can begin to create a sign chart. So I'm going to kind of block off the end here at 0, and I'm going to put pi over 2 on here, and I'm going to put 3 pi over 2 on here, and I'm also going to block off this end at 2 pi to remind me that when I do my test values, I can't go past either one. I have to stay within that interval. So we can test, for instance, at f prime of, let's say, pi over 4. We could look at f prime of pi. We could look at f prime of 3 pi over 4. And we could try to figure out what's going to happen at those places. Now, my expectation is, because I'm squaring the secant, and the secant can't ever be 0, that these things are all going to be positive. And as a matter of fact, if you plug pi over 4 in and figure it out, you'll get a positive value. And if you plug pi in, you'll get a positive value. And if you plug 3 pi over 4 in, you'll get a positive value. So this thing is increasing always. And if you imagine for yourselves what the function tangent looks like, or if you use your calculator and graph the tangent function, there shouldn't be any big surprise here. So our function is increasing on the following intervals. We're going to write them as open intervals, so from 0 to pi over 2, from pi over 2 to 3 pi over 2, and again from 3 pi over 2 to 2 pi. Note that I can't just write this as increasing from 0 to 2 pi because it's not increasing at pi over 2. There's a vertical asymptote there. The function's not even defined at that point. And it's not increasing at 3 pi over 2 because, once again, there's a vertical asymptote there. It's not even a point on the function. So we do need to write these things as 3 different and distinct intervals, because these are the intervals in which the function is defined, and tangent is always increasing at any point within its domain, it turns out.